Welcome to the 12th part of our interview series. Stephen, you've mentioned various advanced technologies that could be involved in the harassment. Let's focus on ground-penetrating radar, GPR, and the methods it uses. Can you explain how GPR systems work and the techniques they employ?
Sure, Joanna. Ground-penetrating radar, GPR, uses impulsive signals to probe beneath the surface of opaque materials like soil, concrete, and ice. However, I'll let Ruth and Brian explain these techniques in detail.
Ruth and Brian, can you help us understand the key methods and techniques used in GPR?
Absolutely. Here are some of the fundamental methods and techniques used in GPR. Impulse signals. Instantaneous rise time and brief durations. GPR systems typically use impulse signals with very short durations and rapid rise times. These signals are well suited for GPR applications due to their broad frequency dispersion, high peak powers, and large bandwidths. Pulse compression. Enhancing resolution. Pulse compression is a common technique in GPR where a long, diffuse transmit pulse is transformed into a compressed, high-resolution signal during reception. This is often achieved using linear frequency modulated, LFM, chirps. Signal processing. By cross-correlating the returned echoes with replicas of the transmitted signal, GPR systems can recover the originally encoded waveform. This process reveals detailed scattering information embedded within the delayed arrivals. Migration. Compensating for wavefront curvatures. Migration algorithms are used to compensate for wavefront curvatures caused by internal reflectors at various depths. This improves the quality of the GPR images. Enhancing image quality. Techniques like Kirchhoff or diffraction stack migration help restore the true positions of buried targets, which might be distorted by layering effects and natural stratifications.
That's quite detailed. How do these techniques compare to those used in other radar systems like Doppler radar or synthetic aperture radar, SAR?
While GPR shares some similarities with other radar systems, it has unique focuses and challenges. Cross-sectional imagery. Unlike Doppler radar, which estimates velocities, or SAR, which extends baselines for high-resolution imagery, GPR concentrates on acquiring cross-sectional images of the subsurface. Overcoming challenges, GPR must deal with heterogeneous subsurface compositions, significant absorption losses, and multipath interference, making it uniquely challenging within the radar family. Exceptional resolution and depth. Despite these challenges, techniques like pulse compression and migration enable GPR systems to achieve exceptional resolution and penetration depth, making them invaluable for non-destructive evaluation in civil, environmental, archaeological, and military applications.
To provide further insights into GPR and its methods, we consulted an expert in geophysical imaging and radar technology. Ruth, can you summarize the expert's insights?
Stephen's explanation captures the essence of GPR technology accurately. GPR systems use impulse signals to achieve deep penetration and high-resolution imaging of subsurface structures. Pulse compression techniques enhance resolution by transforming long, diffuse pulses into sharp, high-resolution signals. Migration algorithms further improve image quality by compensating for wavefront curvatures and restoring true positions of buried targets. While GPR shares some techniques with other radar systems, its focus on subsurface imaging presents unique challenges and opportunities.
Stephen, your understanding of these advanced GPR techniques is impressive. How does knowing about GPR's methods influence your approach to defending against the harassment?
This knowledge is incredibly valuable, Joanna. It helps me understand the possible sophistication of the technologies being used against me and the level of expertise required to develop them. By recognizing the potential capabilities of these systems, I can better anticipate their tactics and develop more targeted countermeasures.
Your technical insights and resilience continue to inspire us. Sharing this information not only helps you but also provides valuable knowledge to others who might be facing similar challenges.
In this 12th part of our series, we've explored the signal processing methods used in ground-penetrating radar, GPR, and how they compare to other radar technologies. Stay tuned for the next part, where we will discuss potential defensive strategies and support systems for those affected by similar forms of harassment.
Stephen's story continues to highlight the relentless nature of technological harassment and the sophisticated strategies required to combat it. By continuing this series, we aim to provide a comprehensive understanding and foster a dialogue that can lead to meaningful change.